Good morning. I welcome you all to this course on compiler design. Um, Myself, I am Sudha Sadasivam. I am working as a professor in Department of CSE. The basic objective of this course is to help the students to learn about the data structures which can be used for the design of compilers. So the course is organized into various modules. This is the first module. In this module, you will be studying about what are the basic contents of this course and what is the process of translation, what is the need to study this particular course, what is the analysis synthesis model of the compiler, and the tools that can be used in the analysis phase, and the difference between compilation and interpretation process. Basically, the course is organized into 6 units. The first unit is an introduction unit, which discusses on the tools that can be used for the process of compilation, the various phases which are involved in the compiler analysis, how the phases can be grouped together, and what are the errors which are encountered in different phases of compilation. The second module deals with the lexical analysis module. This module tells us about the grammar that can be used for the process of lexical analysis, the automaton that can be constructed to recognize this particular grammar, and the tool that can be used for lexical analysis purpose. The third module deals with the second phases of compilation, namely syntax analysis phase. The purpose of this phase is to construct or identify the syntax of a given language. For this purpose, context-free grammars are discussed, along with the automaton that can be used for recognizing the context-free grammars, namely pushdown automaton, and then the type of parsing, namely the top-down and bottom-up parsing, are discussed in detail. The fourth unit deals with the next phase of compilation, namely intermediate code generation. This process mainly identifies the basic intermediate type of code that can be used for optimization purpose, namely tree address code, and how the tree address code can be generated for different types of statements that can be used in the process of compilation. Then the other phases of compilation, namely code optimization and code generation phases, are also discussed. Code optimization phase mainly deals with the local and global data flow analysis, and the code generation deals with the code generation algorithm that can be used with examples. The basic book that can be used is Aho, Ravi Sethi, and Ullman, Compilers, Principles, Techniques, and Tools by Pearson. Next, we will go on to the first phase of compilation, the first module of this course, namely Introduction to Compilers. Here we will discuss about what is meant by translators, the compilation interpretation, what is the difference, and how the phases can be grouped together. In the next module, we will discuss about the phases of compilers in detail. And then in the third module, we'll discuss about the compiler construction tools and grouping of the phases of the compiler. A compiler is basically a translator. So what is a translator? A translator is a software that converts a source text from one language to another language. For example, let us consider we have an input high-level language and an output low-level language. We use a compiler as a translator to convert from the high-level language to a low-level language that the machine can understand. Now, this object code is given an input, which when compiled using this object code produces the desired output. The second type of a translator is one in which we give the input as an assembly level language or an intermediate level language. It translates it into the machine level language that could be understood by the low level machine. To this code, we give the input to obtain the desired output. The third type of the translator is an interpreter. An interpreter is a line-by-line compiler. So it takes as input both the source program as well as the input which is to be given. And then it compiles it line by line and produces the desired output. So the translators from the point of view of system software can be categorized as compilers, interpreters, or assemblers. The language in which the translator is written is called as the implementation language. The input text is written in a format, and this is called as the source program. The output text that is produced by the translator is called as the target program. When the target language in the translator is a low-level language, such a translator is called as a compiler, as we have already discussed. Compiler basically converts a high-level language program into a low-level language program, which could be understood by the machines. So what is known as bootstrapping? When the source language is also the implementation language and the source text to be compiled is actually a new version of the compiler itself, the process is called as bootstrapping. For example, if we have a C compiler and we are trying to extend its features, making use of the same C compiler, then that process is called as bootstrapping. So we will move on to the process of compilation. In this process of compilation, it involves basically the first step, how to design an executable file for a compiler, and how input source program can be given as input to this compiler to produce an output executable object program for the target machine. And this executable program, when it is given an input from the program, gives the actual desired program output. So it involves basically three phases. The first phase is the compiler executable itself. The second phase is generation of an executable file for the program. And the third phase is making use of this executable file and giving the input to the program to this executable file to generate the desired output. Now, we will go on to why such a study of compilers is important. Let us consider driving a car. A driver can utilize the car to the maximum extent only if he has a complete knowledge about the car, or he has a basic knowledge about the components or the working principle in the car, so that if anything goes wrong, he can correct it. Similarly, we as programmers should know how the process of compilation occurs, so that we will be able to write efficient source language programs and optimize source language programs so that it will generate good output. So this field of compiler design, even though it is a very old field and not many people go into this particular line of system software, still it is a very useful field, because most of all the other types of programming techniques are drawn from this. It provides a theoretical and practical knowledge that is needed to implement a particular programming language. We use a lot of sophisticated algorithms and data structures in design of programs, of compilers. So, if we are able to define or design certain components of compilers, then we will be knowing how to effectively use a number of data structures that we have already studied in the earlier semesters. We can also know how to re-engineer complex software systems. Compiler by itself is a very complex system. So if we are even able to add some module or add some commands, we will know how to re-engineer complex software systems. Also, automated tools for migrating applications from one platform to another can be easily understood after reading this particular course on compiler design. The design and implementation of efficient optimization techniques is also possible. Most of the optimization techniques that are used here are also used in the field of software engineering, like flow analysis, control flow diagrams, and so on. This phase of compiler design is very much useful in the field of natural language processing. So all the phases of compilers are used in this particular field. So if you're going to design a natural language processor, you should understand the principles behind the design of compilers. So even though this particular course or contents of the course are very old, still the basic principles are useful for a lot of other new courses or modern courses. The analysis synthesis model of the compiler. Compiler basically consists of two basic phases. One is the analysis phase and the second is the synthesis phase. And hence, the basic model of the compiler is called as analysis synthesis model of the compiler. In this analysis synthesis model of the compiler, first we have to go through certain definitions. The first one is a unit. A unit is nothing but a part of the source program, like an expression. Second is a pass. A pass is nothing but a complete scan of the entire source program or its equivalent. So if you go through and try to generate some representation for an entire source program, it is called as a pass of the compiler. Usually, compiler design comprises of multiple passes. The output of one pass generates the intermediate code that is given as an input to the next pass. This intermediate code is stored in the disk, and the second pass reads the intermediate code from the disk to perform a particular action. What is the need for such multiple passes? There are multiple reasons why the compilers are designed using multiple passes. The first reason is forward reference. Let us consider a go-to statement like go to 100, which is given here. This statement occurs in the position 90 or the 90th statement, but it references to a statement 100, which is 10 statements after it. Hence, the address of this statement 100 is not known. So in that case, this address for this statement 100 will be left unfilled, and later on, during the next pass, when this address is known, during the second pass, this address can get filled. So that is the need for having multiple parses whenever a forward reference occurs. Second is, as we know, the output of each and every pass is stored in a hard disk, but the intermediate representations within a pass is stored in a RAM. So if a single pass output becomes very large, then in that case, lot of RAM space will be required. Hence, if we have multiple passes, the space required to store the intermediate representations in the memory can be reduced. Third is optimization. We have a type of code that is generated in the compilers, which is called as intermediate code. This intermediate code is not dependent on any particular language. So we can use optimization techniques on this intermediate code irrespective of the programming language, making use of abstract representations like control flow graphs and data flow graphs. Hence, usage of multiple parses and generation of intermediate code as an output for a particular pass helps us in optimization, making use of abstract representations that are independent of a programming language. The phases of compilations connected with analysis of the source code forms one pass, and the phases of the compilation or the modules of the compilation connected with generation of the code for the machine forms the second pass. Hence, usually the compiler comprises of two passes. Pass 1, which is called as the analysis pass, which analyzes the source program, and pass 2, which is called as the synthesis pass, which synthesizes or generates the target program. So we will see the analysis synthesis model of the compiler. So in the first phase, it is called as the analysis phase, or also it is called as the front end of the compiler. It performs the analysis of the source program. This analysis is defined by the grammar of the source language. It determines the meaning of the source program or the semantics of the source program. So usually the lexical analysis pass, the syntax analysis module, and the semantic analysis module, all these three modules are grouped together into the analysis or the front-end phase of the compiler. This analysis phase generates a code which is called as the intermediate code, which forms the input to the backend. So the first pass, analysis pass, generates an intermediate code into the hard disk, and this intermediate code generated to the hard disk is read by the backend of the compiler or the synthesis pass of the compiler. The second module, known as the synthesis or the backend module of the compiler, basically deals with generating the target program which could be understood by that particular machine for which the compilation occurs. It generates the target string from the source program using semantic actions in the front end of the compiler. It also depends upon the pragmatics or the execution environment for which it is generating the target code. So the basic purpose of the backend module is to generate the target code which could be understood by the hardware or the machine. So we will see now in this slide what are all the phases that are connected with the analysis pass and what are all the phases which are connected with the synthesis pass of the compiler. Each pass of the compiler consists of a number of phases. What is a phase? A phase is a logically cohesive unit that takes as input one representation of the source program and produces as output another representation of the source program. There are different phases of the compiler. The first three phases of the compiler are connected with the analysis pass. These phases are lexical analysis phase. This phase basically determines the lexical structure of the source string. For example, let us consider a particular statement, I ate an apple. So, all the lexical constituents of this particular statement, namely, I ate an apple, all this forms lexemes or words of the, which are produced as output from the lexical analysis phase. The second phase also does analysis work. What it does is it groups these words which are got as output from the lexical analysis phase into a structure based on the syntax of the language. So it groups these various words or lexemes for the sentence I ate an apple as ate as verb, an apple as noun phrase, I as a pronoun, and forms the structure of the sentence. The third phase is a semantic analysis phase, which tries to understand the context for a particular string. For example, if we consider apple, it may mean different under different contexts. It may mean a fruit or it might mean a type of a computer system. So it will try to understand the context in which apple is used or the semantics for the apple. Based on this statement, the semantics for apple is fruit. So all these phases try to analyze a given source program, and therefore these phases are grouped into the analysis pass of the compiler. The second pass of the compiler is a synthesis pass of the compiler. It basically aims at generating the target code which can be understood by the machine. So the intermediate code generated as output from the analysis pass undergoes optimization in order to reduce the space and to improve on the speed. Then code generation occurs. So all these three phases are grouped together into the synthesis pass of the compiler. So we will see what are all the tools that can be used in different in the analysis model of the compiler. So in the analysis phase, basically it tries to identify the structure of the program. So tools like structure editors can be used. The basic purpose of a structure editors is to form the hierarchical structure of a language. It also tries to identify the keywords and performs parenthesis matching. The second tool is a pretty printer, which tries to indent the code that is given in a particular format and also writes the code in a particular font so that it will be neatly organized. The third type of analysis tool is the static checker, which tries to identify the bugs in a given program. It also identifies the dead portions of the code. Dead portions of the code is nothing but the portions of the code which cannot be used from which cannot be reached from the start. Hence, these portions of the code can be eliminated and hence optimization can be done. The next one is the interpreter. So during the synthesis phase, this interpreter traverses the tree structure that is generated by the analysis phase and does the operation at each node, or execution is done based on the tree structure at each node. So we call that as compilation, line by line compilation as interpretation. Then the next type of analysis tool is the text formatter. This is also used to format the code by setting the paragraphs, figures, and mathematical formula in a particular format. Another analysis tool is the Silicon compiler. The Silicon compiler is similar to any other compiler. It has a high-level language, but the low-level language zeros and ones represent logical signals which can be given as input to a circuit. Such a compiler is said to be a Silicon compiler. The next type of the analysis tool is the query interpreter. This translates a predicate language having relational and Boolean operations into commands which can be used to search a particular database. So it is used to interpret relational queries and convert it into certain queries using which records from the database can be understood, can be read. Next, we will go on to differentiate between a compiler and an interpreter. Already in the initial slide itself, I told that the translators from system programming point of view can be categorized as compilers, assemblers, or interpreters. Both the compilers as well as assemblers convert the output or target output into machine language format, which could be read by the target machine. So in this process, if we see, we have to design a compiler for each and every target machine. For example, if it is an Intel processor, one type of compiler is needed. For Apple type of systems, another type of compiler is needed, and so on. So the compiler, many versions exist for different types of target system, even for a single language. If you consider an interpreter, here the understanding of the intermediate code generated by the interpreter is done by a software which is independent of the underlying hardware. So the interpreters are independent of the target machine. Interpreters are also said to be line-by-line compilers. Now, we will try to understand the difference between a compiler and an interpreter. To design a compiler, more amount of work is needed, and it is also a complex system. It requires more processing. It requires 2 passes, analysis as well as synthesis pass, and hence more processing is involved, whereas an interpreter involves less processing. A compiler generates an exe code, and therefore an input given to the exe code, the output can be generated quickly. So a compiler is fast, whereas an interpreter is slow, because an interpreter tries to generate the output from the syntax tree that has been generated from the intermediate code. So line by line only, it compiles the input to generate the required output. Writing a compiler is a very difficult process, whereas writing an interpreter is a bit easier. The interpreting mechanism for compiler is the CPU or the hardware, whereas for an interpreter, it is a software. Compilers are less secure because it is very easy to hack the executables. Whereas in the case of an interpreter, it is more secure. The intermediate code here generated is low level for a compiler, whereas the intermediate code generated for an interpreter is high level. The compilers, as I already discussed, are not portable. Compilers have to be designed for each and every target language, whereas interpreters are portable because they are designed or they produce output in the form of an intermediate high-level language which can be further processed. Example, Java. We have the bytecode that is being generated. This bytecode is then executed. The compiled code is not portable in the compiler, whereas in the interpreter it is portable. This is how the compilers and interpreters differ. Thank you. Next module, we will discuss about the different phases of compilation.